Good morning. So, in the first part, we have seen about the basic electrophysiology of the heart. So, these are the things we have discussed. So, in the next part, this is the you can say that action potential. Now, we need to discuss about the different phases of a action potential. Now, see, already action potential we have studied in case of the last semester in case of the action potential in the ANS, and here it is into the CVS. That means in the cardiac muscle, action potential in the cardiac muscle. So here again, when you can say that it is the same, when they stimulate, they are depolarized very rapidly. That means these cells are depolarizing the very rapidly. And why this happening? What is the reason of this depolarization? Of course, the opening of the sodium channel, mainly the sodium channel, or you can say that calcium channels also it is responsible for this depolarization generally. In general, I am telling. Next is phase 1, rapid return to the isoelectric level. So it is rapid declining into the isoelectric level. So here the membrane potential rise up to plus 20 millivolt, clear, plus 20 millivolt. Now next is phase 2, clear. Phase 2, in this maintains the action potential for some time, during which calcium ion flow in and bring the contraction. So here what will happen, you can say that in this case what is happening, why it is dropping down, because the sodium channel is getting close, clear. Sodium channel is getting close here, and here what will happen in the phase 2, maintains the membrane potential for sometimes, during which calcium ion flow, clear, calcium ion flow, see, sodium is blocked, calcium is flow, so it is maintaining a balance, and it is and bring the contraction. Next is phase 3. This is again comes the repolarization, rapid repolarization during sodium and potassium pump activates. So sodium potassium pump means again here the potassium, it is you can say that goes out, potassium goes out means positive charge ion goes out, positive charge ion goes out means membrane potential is coming down. So that is we are calling as a repolarization. And then that is the RMP, that is the rapid action potential, which is attained and does not decay. So this is about the general action potential. But of course, whenever we are talking about the heart, and we will see about the different parts of the heart, for example SA node, AV node, we will see that what is the difference. Now here we are talking about the some of the fast action potential and slow action potential. So you can find out what is the difference between the fast action potential and slow action potential. What will happen in case of the fast action potential, it is almost near about 85 and all, and it is rises up to plus 20, and then it will come down. So this is the threshold, and again it will go up. Now what will happen in case of the slow channel? Slow channel means it is slowly it will be activate, and it will not cause the action potential, it will not go almost, it will near to the zero, and then again it will go down. So in case of the why we are showing this, for example, fast action potential channels where it's in the atria, ventricles, Purkinje fibers. And what is the predominant in the zero phase? Zero phase means here sodium, and then here slow channel action potential, SA node, AV node, around AV node ring, coronary sinus, and what is important, calcium, clear, calcium. Now activation and inactivation kinetic fast, of course we can say that it is fast, but this is slow. And channel activation, it is the voltage dependent, clear, it is the voltage dependent, the which one, first. And slow action potential channel, that is the time dependent. Activate potential, that means threshold voltage. What is threshold? In the threshold in the particular area when it is opening. Now minor, all are opening and rapid depolarization start, that is the minus 60 to minus 70 millivolt, and for the slow, that is the minus 45 to minus 55 millivolt. Contraction velocity 0.5 to 1 m per second, and in case of the slow 0.01 to 0.1 m per second. So this is about the difference about the fast and slow. Now coming to the electrophysiology of the heart. Now here you can find that what is the difference between the different electrophysiology. Now for example SA node, if we are considering the SA node, the action potential which generates into the SA node, it will be like that. Clear? SA node, it will be like that. Clear? So here you can find. Clear? Here you can find. So here the calcium channel open. Why it is the calcium channel open? Because already we have told, in case of the SA node, predominant thing is the calcium. So calcium channel open, then again calcium channel close, potassium channel open. So of course calcium permeability decrease because calcium channel is closed, but potassium channel is open, so potassium permeability increase. So this is, we are talking about the action potential. Now if you talking about the atria, if you see about the atria, you can find that what is the difference. You can action potential. Clear? Action potential, this is again fast and slow, all those things it is there. And in case of the AV node, again you can find this is the AV node. Clear? AV node, and this is into the ventricles muscle. Clear? So you can find that different type of if we are plotting the graph, there is a different type of the conduction it is happening, but ultimately it is, see, all the phases are there, like a phase 0, phase 1, phase 2, phase 3 is there, but of course due to the fast and slow and the conduction velocity, it is different. So again it is, here we are coming. Now here you can find that again, now here again we are considering the all. Now whenever we are talking about this electrophysiology, how we are evaluating whether heartbeat is proper or not, of course through the ECG. Now ECG graph, if you see about the ECG graph, you may find that this is the ECG graph. Clear? This is the ECG graph. Now how this ECG graph is came like that, so this is the explanation. Clear? This is the explanation. Now we need to consider all the action potential which is generating from the different parts of the heart. Clear? It is not only it is responsible on the SA node or it is only the AV node, it is responsible for the all. Now coming to the SA node, so you can find that what is the action potential, already we have told. Next is in the atria muscle. Clear? This is the atrial muscle. In the atrial muscle, the depolarization is very fast. You can find that depolarization is very fast. Then again rapid repolarization, you can find that AV node, of course this is first, but not like that the atria muscle, and then you can say that again it is coming down. In case of the common bundles, common means bundle of his before the branching, it is like that, again very fast depolarization, then again it is you can say that maintaining some balance, and then again you can find a slow repolarization. Next is bundle of branches, again almost it is the same. Of course you can find it will taking the more time for the repolarization. Next is Purkinje fiber, again you can find that fast action potential generation, and then there is a slowly their repolarization is done, and this is the ventricle muscle action potential. So if we are combining all those, we are getting the ECG, that is the PQRSTU. Clear? PQRSTU, and this is the time. Clear? This is the time. This is the second, 0.2, 0.4 and 0.6 second. So this is about the electrophysiology of heart. That means in the all the part there is the action potential. We need to consider all the action potential, and we need to draw the curve. So here you can find that in the which second it is producing the action potential, and when it will be repolarization, that we can identify from here. So again here in case of the cardiac electrophysiology, so if we are considering the cardiac electrophysiology, already as we have told PQRSTU, so this is the T wave produced as impulse from the SA node and caused the atrial contraction. So it is P wave, you can find that SA node and is responsible for the atrial contraction. QRS complex, which one? QRS complex, and this one, conduction of impulse through the bundle of his to the Purkinje fibers. Clear? So this is the to the Purkinje fibers from the bundle of his. Next is ST segment, the heart's resting potential. So ST is the heart, this particular thing, resting potential. T wave, ventricular repolarization. Clear? T wave, ventricular repolarization, and this is the different parts. And PR interval, this is time between the atrial depolarization uh, and the ventricular conduction. So this is, you can say that, about the electrophysiology of the heart. So in the next part we will see about the this graph in the details along with the its importance.